Alright, so this is chapter 9, random variable. So today we are going to focus on the discrete random variable. Okay, so if x is a discrete random variable, then the first one, the probability for x equal to x should be somewhere in between 0 and 1. And the second one, the summation of the probability should be equal to 1. So if you take the probability, you add everything together, it should be the sample space which is equal to 1. Okay, so the probability distribution can be represented in the form of table, function, and graph. Okay, so for the table, you might need to have the x up and then probability for x equal to x below. So the x can be, let's say, perhaps 1, 2, and 3, and then you can write down the probability over here. So this one might be 0.2, 0.3, 0.5. So this is how we draw our table. So to draw the function, we have to write down px equal to x, and then the function you need to have the set notation. So 0.2 for x equal to 1, 0.3 when x is equal to 2, and then 0.5 when x is equal to 3. So these are table and those are the function. Okay, so what do we mean by the graph? So for the graph, so this is for px equal to x, and then you're gonna have the x-axis, so this is the x, and then your x is 1, 2, and 3, so 1, 2, 3. So for the probability, to make sure this one, you need to make it a little bit scale. So that means if this one is 0.2, 0.3 is definitely higher. So 0.3, 0.5 needs to be higher than that. So 1, this is a vertical line at 1, so this is 0.2. At 2, 0.3, so a vertical line again. And then 3, 0.5, so again it should be a line. Not really a straight line, but you know what do I mean, right? Okay, so now let us do the first exercise. So let x represent the number of girls for a family of 4 children. List the values of x and compute the probability function of x. Okay, so since we have 4 children, the first children can either be a girl or a boy. So this is for the first children, so the first child. And then the second child can either be a girl and a boy as well. So this is for the second child. And then of course you have the third child. So again, a girl and a boy. So this is the third child. So girl and boy, girl and boy, girl and boy. So this is the third child. So now since we have 4 children, we need to have one more. So G, B, 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 and GB. So this is the fourth child. So if the first one is a girl, the second one is a girl, the third one is a girl, the fourth one is a girl, then our outcome will be G, 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 G. So if you list down all possible outcome, you might have G, 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 or G, 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 B, or you might have G, G, B, G, or G, G, B, B. You might have G, B, G, G, or you might have G, B, G, B, or G, B, B, G, or G, B, B, B. So G, 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 B, G, G, B, G, 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 B, B, G, B, G, 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 B, G, B, G, B, B, G, G, B, B, B. And of course, you're gonna have the same thing, but starting with B. So we might have B, G, 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 B, G, G, B, B, G, B, G, B, G, B, 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 G, G, B, B, G, B, 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 G, B, 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 B. Okay, so we say that X represent the number of girls. So X is the number of girls. So now let us see one by one. And so this is 4 girls, 3 girls, 3 girls, and so on. So firstly, let us calculate the probability for each of them first. So I need to calculate the probability. Okay, so let us write down the probability for G and B. So the possibility to get a girl and a boy is a fair one. So this is 1/2. This is also 1/2. So for each of them, this is simply 1/2, 1/2, 1/2, 1/2, 1/2. Okay, so now let us calculate the probability of girl, 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 girl. So since this is B of G, 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 so you have to multiply along the branch. So 1/2, 1/2, 1/2, 1/2. So this is simply equal to 1/16. G, 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 B. So again, at the end over here, so multiply along the branch, we're gonna get the same thing. So 1/16. So this one also, you multiply along the branch, so 1/16 as well. Multiply along the branch, 1/16, and in fact, everything is 1/16. Okay, so now let us list down the value of X for each of them. Okay, so this one over here, we have 4 girls. So this one is X equal to 4. This one is X equal to 3. X equal to 3. X equal to 2 because we have 2 girls. And then X equal to 3. X equal to 2. X equal to 2. X equal to 1. And then this one is X equal to 3. X equal to 2. X equal to 2. And this one is X equal to 1, X equal to 2, X equal to 1, X equal to 1, and X equal to 0. Okay, so now let us list down the values of X. As you can see, your X starting from 0 up until 4. So let us do the table for it. Okay, so we have X equal to 0, 1, 2, 3, and 4. And then we have to calculate what is the probability. So go back to your tree diagram and then check how many X equal to 0 do you have. Okay, so X equal to 0, we only have 1 over here, and the probability is 1/16. So simply take the probability. So this is 1/16. Okay, so now for X equal to 1, I have 1, 2, 3, 4. So I have 4 of them. So that means this one should be 4 multiplied with 1/16, which is simply 4/16. So this is 1/4. Okay, so now for X equal to 2. So 1, 2, 3, 4, 5, 6. So I have 6 of them. So this one should be 6 multiplied with 1/16. So this one will be 6/16, or we're going to have 3/8. Okay, so now for X equal to 3. So we have 1, 2, 3, 4, and that's all, 4. So that means this one is 4 multiplied with 1 over 16. So this is 1 over 4 as well. So now for x equal to 4, so we only have one of them over here. So this is simply 1 over 16. Okay, so since they do want the probability distribution function, you have to write down probability for x equal to x. So this is equal to, so the lowest value is 1 over 16. So this is for x equal to 0 and 4. And then of course 1 over 4. So this is for x equal to 1 and 3. And then you have 3 over 8. So this is when x equal to 2. And then of course you need to write down one more, 0 elsewhere, or you can use 0 otherwise. Either one. So what do we mean by 0 otherwise or 0 elsewhere? Is that if let's say you want to calculate the probability for x equal to 5, we do know that the value must be equal to 0, because other than this value, everything else is 0. So let us go to the second example. The probability distribution function of a discrete random variable x is given by, so px equal to x is kx squared for x equal to 0, 1, 2, 3, 4. Find the value of the constant k. So whenever you have a discrete random variable, it will be a good idea to write down the table first, or to prepare the table for it. So let us have the x, and then the px equal to x. So we have 0, 1, 2, 3, 4. So 0, 1, 2, 3, and 4. Okay, so how do we calculate the probability? So for x equal to 0, you simply replace the x with 0. So we're gonna get 0 square multiplied with k. So 0 square is simply 0. 0 multiplied with k is simply 0. Substitute x with 1, we're gonna get a k. 2 square is 4, so this is 4k, 9k, and of course 16k. So to calculate the value of the constant k, we have to use the summation for probability of x equal to x. So this is actually equal to 1. So that means k plus with 4k plus with 9k plus with 16k altogether must be equal to 1. So if you add everything together, this one should be 10, 20, so 30k is equal to 1. K must be 1 over 30. Okay, so this is A. So B, find the probability distribution function. So let us substitute the k with 1 over 30. So this is still a 0. So this is probability of x equal to x again. So 0, k is 1 over 30, this is 4 over 30, 9 over 30, and then of course 16 over 30. Okay, so we need to have the probability distribution function. So probability of x equal to x. So let us start with 1 over 30. So this is for x equal to 1. 4 over 30, so this is 2 over 15. So this is when x equal to 2. 9 over 30, so divide them by 3, we got 3 over 10. So this is when x equal to 3. 16 over 30, so we can actually simplify them to become 8 over 15. So this is when x equal to, and of course you have one extra thing, which is 0 for elsewhere. Okay, so now let us answer C. C, calculate the probability for x equal to 1 or x equal to 4. So let me squeeze them a little bit over here. So for C, probability of x equal to 1 or x equal to 4. So that simply means probability of x equal to 1 plus with probability of x equal to 4. So now substitute x equal to 1. So the value is 1 over 30 plus with x equal to 4, which is 16 over 30. So adding them together, so this is 17 over 30. So this is the answer for part C. for part D, so this is one extra thing that you have to remember from the first sem. We have to calculate the probability of modulus of x minus 2 less than 1. So we have to open the modulus first before we know what do we want to calculate. Okay, so what do we want to calculate is the probability of x minus 2 less than 1. So I have to solve the thing inside here first. So let us go to the right hand side. So modulus of x minus 2 less than 1. So when you open the modulus, less than is something in between. So negative 1 and 1. So that means x will be negative 1 plus 2, which is 1. 1 plus 2, which is 3. So instead of writing down probability of modulus of x minus 2 less than 1, I'm going to write them down as probability for x in between 1 and 3. And of course, since this is a discrete, so probability of x in between 1 and 3, that simply means probability of x equal to 2. So go back to the table, and probability of x equal to 2 is simply 4 over 30, or you can simplify them as 2 over 15. Okay, so that's it for the first part.